This is a video tutorial for tutorial 3A question 6. 3A question 6 gives us a curve and it tells us that it's got the equation y equals to x plus a squared over x plus b and asks us to find the values of a and b given that there is a stationary point at 1, 0. So how do we find the values of a and b? Well, first thing we do is we look at the curve and we recognize that there is a vertical asymptote at x equals to negative 2. So if x equals to negative 2 is an asymptote, that means that b is equal to 2, because then negative 2 plus 2 equals to 0 gives us that divide by 0 error, which means that I would get a vertical asymptote. To find out the value for a, I just substitute in this value. So when x equals to 1, y equals to 0. So 0 is equal to 1 plus a squared over 1 plus b, and that straight away gives us that a equals to negative 1. So we've got a equals to negative 1, b equals to 2. That's our answer for part 1. Just to conclude, it means that the equation for my graph is now y is equal to x minus 1 squared over x plus 2, which is the same thing as writing x squared minus 2x plus 1 over x plus 2. Part 2, find the equation of the oblique asymptote L. So to do this, we need to do long division. So currently, this is an improper fraction. So we do long division to turn it into a proper fraction. So x plus 2 divides x squared plus, minus, where's the undo button? Never mind. Oh, can't do that. X squared minus 2x plus 1. And when we do this, to eliminate the x, we multiply x plus 2 by x. We get minus x plus 2x. That gives us 0x squared minus 4x plus 1. So to turn x into minus 4x, we multiply by minus 4. So we get minus 4x minus 8. And this becomes 9. So our equation is actually the same thing as y equals to x minus 4 plus 9 over x plus 2. Therefore L, the equation for L is y is equal to x minus 4. Since as x goes to positive or negative infinity, this term, 9 over x plus 2, decays towards 0. So what about coordinates for the other turning point? Well, to find those, what we need to do is first of all differentiate y. So dy by dx. Now often I find it easier to differentiate this form of the equation here rather than differentiating our original form up here. And the reason is that this one doesn't require me to use the quotient rule or anything like that. It just requires me to know a little bit about the power rule and maybe, if I'm unlucky, the chain rule. So I'm going to differentiate this one. So dy dx is equal to, differentiate x, I get 1, differentiate minus 4, it disappears, differentiate 9, x plus 2 to the negative 1, negative 1 comes down, I get minus, 9 stays there, x plus 2, decrease the power by 1, and then multiply by the derivative of the inside, which is the derivative of this, which is just going to be 1, so nothing changes. I want a stationary point, so I set this equal to 0 for stationary points. This is the same thing as saying 1 is equal to 9, x plus 2 to the negative 2. Same thing as saying x plus 2 squared is equal to 9. X plus 2 is equal to positive or negative 3. And that means that x equals to 1, which I already knew, or x equals to minus 5, which is the new one, the coordinate for p. So I'm going to use this one. When x equals to minus 5, y equals to, and again I'm going to use, I'll use this formula this time, minus 5 minus 1 squared over minus 5 plus 2, that becomes minus 5 minus 1 is negative 6. Squared becomes 36. Divided by negative 5 plus 2 is negative 3. So this whole thing is negative 12. So therefore, my point P is negative 5, negative 12. Part 4, copy the above sketch and on the same diagram draw a sketch of x squared plus y squared is equal to 16. So let's copy that sketch first. We know the equation is y equals 2 x minus 1 squared over x plus 2. So I've keyed this into GeoGebra. Might need to just zoom out a little bit. It's possibly am I zooming in or zooming out? I can't control the zoom very well. Okay, so now you can see the shape of this graph. And the other equation I need to key in is x squared plus y squared equals to 16. So key that in, you see that I get this circle here with radius 4. So again, let me just zoom back in so we can see it a little bit better. Oh, I don't want that selected. Zoom, we'll go back to zoom of 50%. No, oops, sorry. Zoom of, let's zoom in again. Okay, so circle, radius 4, centered on the origin. And so our axial intercepts are going to be minus 4, minus 4, 4, 4. Hence show that this final equation has two real roots. So hence means that we need to use this part 4 in some way. One way you may think of, you see that this one has 2 points of intersection with the original curve. So you know that if you substituted y into the equation for the circle, that equation would have two real roots. So we're going to try and do that. We're going to substitute y in. So I'm going to start with x squared plus y squared equals to 16. And I'm starting with this one because it is simpler. So I want to go from something simple to something complicated. I'm going to sub in y equals to x minus 1 squared over x plus 2, which if you recall was the equation for the curve C. So I get x squared plus, substituting in, x minus 1 squared over x plus 2, whole thing squared equals to 16. This gives me x squared plus x minus 1 to the power of 4 over x plus 2 squared equals to 16. Multiply the whole equation through by x plus 2 squared, I get x squared x plus 2 squared plus x minus 1 to the power of 4 equals to 16 x plus 2 squared. Time to expand out. X squared times x squared plus 4x plus 4 plus, expanding out this one using the binomial expansion, we get x to the 4 minus 4x cubed plus 6x squared minus 4x plus 1 is equal to, and again expanding this out, 16 x squared plus 4x plus 4. What does that give me? That gives me x to the 4 plus 4x cubed plus 4x squared plus x to the 4 minus 4x cubed, so that's going to cancel with that, plus 6x squared minus 4x plus 1 is equal to 16x squared plus 64x plus 64. Moving that all over to one side, I get 2x to the power of 4, from the 2x is the power of 4, 0x to the power of 3, 4x squared plus 6x squared is 10x squared minus 16x squared gives me minus 6x squared. Then I get minus 4x minus 64x, so minus 68x, 1 minus 64 minus 63 equals to 0. Therefore, since the circle and curve have 2 points of intersection, the above equation has two real roots. And that's it for question 5.